Welcome, students. In this video, we'll be computing an exercise that requires to find a force in linear acceleration. So for that, we're gonna need Newton's second law. We're gonna need basically this problem can be solved using Newton's laws and some basic kinematic equations. Okay, so the exercise that we're gonna be working is as follows. It says that a particle accelerator propels a helium ion with a mass of 6.6 times 10 to the negative 27 kilograms from rest to a velocity of 5.8 times 10 to the 6 meters per second over a time interval of 4.8 times 10 to the minus 6 seconds. So what is the magnitude of the force required to achieve this acceleration? So when they said force, we probably have to start thinking about Newton's second law that says force equals ma, force equals mass times acceleration. And what do they give us? What does that formula requires? It requires mass and acceleration. So if we have mass and the acceleration of the helium ion, then we can compute the force required to achieve the acceleration. Okay, so in the prompt they gave us that the mass is given 6.6 times 10 to the negative 27 kilograms. So that we already have. So the mass we already have, but we need to compute the acceleration, and for that we're gonna use other data that is given. We're gonna use the velocity and the time interval. Okay, so to find the force, we first need to calculate the acceleration using the formula. Acceleration is equal to final velocity minus initial velocity over time. So since the helium ion starts from rest, the initial velocity is 0. That means that at time 0, the initial velocity is equal to 0. And this is how we compute the acceleration. So final velocity is of course going to be 5.8 times 10 to the 6, and then we subtract minus 0 because that's the initial velocity, and then we divide it by the time interval, which is 4.8 times 10 to the negative 6. When we compute that on the calculator, we get that is approximately 1.21 times 10 to the 12 meters per second squared. If you do this on the calculator, what you can do is you can divide 5.8 divided by 4.8 and you get 1.21, and then you subtract the exponent. So 6 minus becomes plus, so 6 plus 6 is 12, and that's how they get the 12 here. Okay, so now we're gonna use Newton's second law that says that force equals mass times acceleration. Now we have the acceleration and we have the mass. Also, all we have to do is plug those two quantities, and we're gonna get a force that is approximately to 7.986 times 10 to the negative 15 newtons. So that's the magnitude of the force that is required to achieve the acceleration. The acceleration, which is 1.21 times 10 to the 12 meters per second squared. Thank you for watching. Please subscribe, and I hope you like my videos.